Today, we're talking ghost particles, and no, that's not what's left over after a spirit gets Holtzmaned.
Let's go. You just got Holtzmaned, baby!
What? I like the reboot. Fight me. Hey everyone, welcome back to the STEMulus. I'm Steph, and here's what happened this week in STEM. A long time ago, in a galaxy pretty far away, a supermassive black hole puked out a powerful jet of radiation containing subatomic particles called neutrinos. We call these little guys ghost particles because they are dang near impossible to detect. Fast forward 4 billion years to the present day at Earth's South Pole, where 5,160 sensors buried more than a mile beneath the ice detect a single neutrino interacting with an atom. Not only were scientists able to detect this incredibly elusive particle, but they were also able to trace it back to the exact galaxy it came from 4 billion years ago. Now, what exactly makes neutrinos so ghostly? They're not rare. In fact, they're the second most abundant particle in the universe after photons. As you're watching this video, trillions of ghost particles are streaming through your body every second. Ooh. However, they are so tiny that they rarely bump into atoms, and therefore are incredibly hard to detect. They're nearly massless and have no electric charge, so they really don't interact with other atoms. We can't feel them, and they don't shed any light, so we can't see them. But it's these factors that make them the perfect interstellar travelers. Nothing can block them or bend them like light or gravitational waves, so they get to cruise around the universe pretty much uninhibited. Most of the neutrinos around us come from the sun, but a small percentage that have extremely high energies can go shooting across space, like the one that the scientists detected. For this neutrino, scientists were able to trace it back to a type of galaxy called a blazar. Blazars are galaxies that are oriented such that jets of radiation emitting from the fast-spinning supermassive black hole at their center are pointed towards Earth. Since cosmic neutrinos and cosmic rays kind of go hand in hand, this new discovery also indicates that blazars are the source of cosmic rays, a mystery scientists have been working to solve since cosmic rays were first detected in 1912. So how do we detect these high-energy cosmic neutrinos here on Earth if they're so elusive? In this case, the cosmic neutrino was detected at the Ice Cube Neutrino Observatory at the South Pole. Built in 2005 by the National Science Foundation, the observatory uses a grid array of sensors consisting of 86 cables holding 60 basketball-sized light sensors each. These cables and their sensors extend about 1.5 miles into the glacier and are designed to pick up blue light, which is emitted after a neutrino interacts with an atomic nucleus. It's necessary to bury the sensors deep into the ice to weed out any non-high energy cosmic neutrinos from being detected. Even with this massive array of equipment covering roughly 1 cubic kilometer, the ice cube only finds a few hundred neutrinos each year, detecting its first ever confirmed neutrino from beyond the Milky Way in 2013. At the time, they weren't able to pinpoint where the neutrinos came from, but that all changed in September of 2017. On September 22, 2017, the ice cube detected an extremely energetic cosmic neutrino that was carrying nearly 50 times more energy than the protons cycling through the Large Hadron Collider. Within 1 minute of detection, an alert was sent out to astronomers around the globe, and using around 20 different telescopes, the community was able to trace the neutrino to an already known blazar, which is around 4 billion light years from Earth. So why is this a big deal aside from being an incredibly impressive discovery? Well, scientists refer to things like radio waves, gravitational waves, or in this case neutrinos, that produce signals that can be detected through space as messengers. These messengers play an important role in helping scientists understand the cosmic and chaotic phenomena that are taking place in galaxies billions of light years away, and gives us just a few more puzzle pieces in our quest to understanding everything that goes on in our universe. So that brings us to our question of the day. Out of all the incredible things that go on in our universe, what's one tidbit that always leaves you in awe? The expansion of the universe, black holes? Let me know in the comment section down below. As always, if you want to check out this story a little bit more in depth, I will include links to my sources down below, along with links to all of my social media and my Patreon page, so feel free to check that out in your free time. If you like this video and you want to see more like it, please feel free to give it a big thumbs up and subscribe to the channel so you never miss out on any of my future STEM-related content. If you see any cool current STEM-related news stories throughout the week, please feel free to send me a link on the STEMulus Facebook page or on Twitter at @TheSTEMulus using the hashtag TWISTEM, and they just might make it into an episode. But with that, I hope you all have a wonderful rest of your week. Stay well, stay awesome, and I will see you next time.